Okay guys, today we are doing the second half of our polygons mini unit, and there are two objectives that we're doing today. I can correctly identify polygons and find the interior sum of their angles, and I can use the interior sum of a polygon to solve for a missing variable. Now I know you are doing these notes digitally, so just do your best to type everything out, but if you miss something, the key is posted, and then you're also welcome to do any of the written problems on a piece of notebook paper, just so you have them for reference later. So let's start out filling these definitions. A polygon is a closed plane figure made up of 3 or more line segments that intersect only at their endpoints. And so you can see visually what kind of happens with polygons. All of the sides have to be straight line segments. They can only connect at their ends, so you can't have any curves. You can't have any line segments that kind of overlap each other or run into each other. You just have to have a bunch of segments that are connected and connected only at their endpoints. So that's kind of what's going on in these polygon examples. So again, these are polygons, these are not polygons. You may have used the triangle sum theorem in the past, which says that the interior sum of every triangle is equal to 180 degrees. However, the interior angles of polygons all have different interior measures based on the number of sides of the polygon. And that's what we talked about in class the other day, using that formula, which is right here. So the interior angle measures of a polygon, the sum S of the interior angle measures of a polygon with n sides is n minus 2 times 180. So just like we did the other day, all you're going to do if you want to find the interior angle sum for the following polygons is you can follow these steps. But first you're going to figure out if you have a polygon. A, B, C, D, and E are all polygons, or actually 2 are pictures of them, and then C, D, and E just say how many sided polygon you have. You're going to count the number of sides. Take the number of sides and subtract 2 from it, and then multiply the new number by 180. So again, you can kind of type out this process, or if you want to switch to notebook paper for now, you could probably use notebook paper for the rest of these notes. So on example A, I need to know how many sides I have. So I have 1, 2, 3, 4 sides. So you're going to have 4 minus 2 in parentheses, and then you're going to multiply that by 180. You always simplify the sides minus 2 first. So I'm going to have 2 times 180, which gives me 360 degrees. So for this 4-sided polygon, it's a quadrilateral is what we call that, we have an interior sum of 360 degrees. Same thing we're going to do on example B. 1, 2, 3, 4, 5 sides. So you're going to do 5 minus 2 times 180. Always simplify the sides minus 2 first. So you get 3 times 180. So the interior measure for that polygon is 540 degrees. Now, this does get a little bit trickier, or the numbers get a little bit bigger when you have larger polygons. So you really want to use the formula when you have a 10-sided polygon or a 15-sided polygon, just because you're probably not going to have that interior sum memorized. So if you have a 10-sided polygon, you're just going to do 10 minus 2 times 180. That gives you 8 times 180, which would be 1,440 degrees. And then I suggest you pause the video and do D and E on your own. So hopefully you paused the video and tried these on your own. For D, you would have 7 minus 2 times 180, so 5 times 180, which is 900 degrees. And then for E, you'd have 15 minus 2 times 180, which is 13 times 180, which is 2,340 degrees. So again, we haven't really done anything new. That's what we did on the previous page. But now we need to extend that to do problems like we have on the back. So in the following examples, find the angle sum first, and then set up an equation and solve for the missing variable. So the only difference on this page versus the back page is we are applying the angle sum into a problem where we're solving for a missing variable. So the first thing you're going to do on each of these problems is first figure out what the interior angle sum would be. So this is a three-sided figure. So I would use 3 minus 2 times 180, 1 times 180. Oh yeah, remember it's a triangle, so the interior sum is 180 degrees. But then you have to do a second step. We know that the interior angles of the triangle are H, 62, and 88. So my final step is going to be using those interior angles, adding them up, setting them equal to 180, and then solving for that missing measure. So I should be able to figure out what H would equal. So H plus 88 plus 62 equals 180 degrees. I have like terms, so I would get H plus 150 equals 180 degrees. And then to get H alone, I can subtract 150 from both sides. So I get H equals 30 degrees. So again, first I had to figure out what the interior angle sum would be based on the number of sides. Then I'm going to set all of those interior measures up so that they're being added and they equal that interior sum, and then we're going to solve for the missing variable. So let's repeat this process with example G. First, figure out how many sides you have on your figure. This is a four-sided figure. So I'm going to do 4 minus 2 times 180, 2 times 180, so 360 degrees. Again, if you're having to type this and you're going slower, you're always welcome to pause, or you can do this on notebook paper. You just need to be able to reference it on Monday. Then I'm going to take all of my interior measures and add them up so that they equal 360 degrees. So this one's a little kind of weird looking, but I'm going to have C plus 25 plus 30 plus 60 equals 360 degrees. I actually have three different like terms, so I'm going to have to add up 25 plus 30 plus 60, which is going to get me C plus 115 equals 360 degrees. And then I'm going to subtract 115 from both sides. So I get that C equals 245 degrees. H is very similar to G, so go ahead, pause the video, try H on your own, and then we can do I together. So hopefully you paused the video and figured out that H has four sides. So you do 4 minus 2 times 180, 2 times 180, or 360 degrees. Again, anytime you have a quadrilateral, the interior angles add up to 360 degrees. We're going to add up all the parts. So L plus 90 plus 95 plus 40 equals 360 degrees. I have like terms. So L plus 225 equals 360 degrees. And then I would subtract 225 from both sides. So I'd get that L is 135 degrees. You can also take a look at L and say, oh, that's obtuse. It's bigger than 90 degrees. It actually does visually look like a 135 degree angle. Perhaps the trickiest one, just because it has most sides, would be the last one. And again, I like to go through and draw those little dashes to figure out exactly how many sides I have. So this is a 6-sided figure. So I do 6 minus 2 times 180, or 4 times 180, which gives me 720 degrees. So when I go and add up all of my angles, and there is a bunch, I'll have B plus, it's a good idea to go either clockwise or counterclockwise, whichever one you prefer. So I just kind of go around to the right. B plus 160 plus 85 plus 135 plus 140 plus 90 equals 720. There are a ton of like terms on this one. So you could just put all those in your calculator and you'd get that B plus 610 equals 720. And then the last step would be subtracting 610 from both sides. So I think the final answer for B would be 110 degrees. So I know that was a short lesson. You probably had to pause it a bit so that you could either type or write all these examples down. You do have a worksheet that is super similar to this. So go complete that worksheet. I think it only has like 6 or 8 questions on it. Check your work, and then you are done. Have a great weekend.